Now next one is reversible and irreversible processes. Reversible process means a process is said to be reversible if in case it is carried out infinitesimally slowly means a reaction which takes place or process which takes place very slowly. So that all changes occurring in the direct process can be exactly reversed, and the system and surrounding remain in a state of equilibrium. Okay, at any stage of the process. Now, what do you mean by all this? Means, first of all, it is carried out infinitesimally slowly, and all changes which are occurring in the process can be exactly reversed. So, to some extent, Ralam, you are right, but keep in mind it is like a process is going infinitesimally slowly. Means there are series of processes, and every process is occurring like this, so that it can be reversed at every stage. Okay, but it is going forward, right? It is like this. Okay, very slowly it is going forward, but very slowly, and at every stage system and surrounding they are in equilibrium. Okay, that is called reversible process. Means a reaction or process takes place in many steps. It is not a single step process. It means process takes place in more than one step. It is not a single step reaction or process, right? And system and surrounding are always in equilibrium with each other, so that we can reverse it at any stage by applying infinitesimally small amount of force or energy or pressure, whatever. Now, next is irreversible process. Yes, it is just like staircase. Okay, means it go like this. It is not for a irreversible process, it is like this only, single step. But in reversible, it is like this. It can go to this stage, but in many steps. But in irreversible process, it is a single step reaction and it cannot be reversed at any stage. So next is irreversible process. So it is a process in which the change is carried out rapidly and the system does not have chance to achieve equilibrium. See, just reversed. In reversible process, reaction is infinitesimally slow. Process is infinitesimally slow. But in irreversible, it is rapid. In reversible process, system and surrounding, they are always in equilibrium. But in this case, reaction is so fast that it cannot have chance to achieve equilibrium. That means driving force and opposing force. जैसे आपको पता है, लेट अस टेक अ बस. ओके, अब बस को या बहुत बड़े ब्लॉक को बस लेते हैं, चलो, क्योंकि बस का एग्जांपल एक लाइव एग्जांपल हो जाएगा ना. बस ली हमने और एक ही बंदा उसको ना, बिल्कुल प्लेन रोड है, बट ओनली वन पर्सन इज अप्लाइंग फोर्स. ओनली वन पर्सन इज अप्लाइंग फोर्स. व्हाट हैपेंड? बस slightly move and then come back. Okay, slightly move and come back. So that means that is one type of reversible process. Okay, because driving force and opposing force, they are almost equal. एक तो चांस ये है कि वो हिले ही ना, ऐसा बंदा हो जिसको इतना ज़्यादा मतलब फोर्स उस लगा ही ना पाए कि वो हिले. बट एक है कि पर्सन ऐसा है जो उसको हिला पा रहा है बस को, है ना. तो वो थोड़ा सा हिलाएगा वापस आ जाएगी, थोड़ा सा हिलाएगा वापस आ जाएगी, या थोड़ी आगे भी जाएगी तो फिर थोड़ा सा बैक आ जाएगी. सो दैट टाइप ऑफ थिंग इज कॉल्ड रिवर्सिबल प्रोसेस. बट अगर एक्चुअल में किसी बस को आप धक्का मारोगे तो एटलीस्ट 3-4 पर्सन आर रिक्वायर्ड. सो 3-4 पर्सन अगर धक्का देंगे तो एक ही टाइम पे प्लेन रोड में चली जाएगी आगे. तो इफ देयर इज अ लार्ज डिफरेंस बिटवीन द ड्राइविंग फोर्स and opposing force, okay, so that is called, yes, if there is a large difference between the driving force and opposing force. What do we mean by driving force? Driving force means the force which drives the reactants toward the product. Good evening, Abhijit. Driving force means the force, it's okay, Abhijit, the force which drive the reactants towards the products. Okay, and The opposing force, so it is carried, it is to carry the process in the reverse direction, means it is to carry reverse process. Okay. So if driving force and opposing force, there is a large difference, that is called irreversible process. Okay. And if driving force and opposing force is almost equal, then that is called reversible process. Any doubt with regard to reversible and irreversible process? Yes. Reversible and irreversible process, is it clear to you all? Yes beta, tell me, have you any doubt? Okay. So once again I am repeating, reversible means which is carried out infinitesimally slowly, and in every stage the system and surrounding are in equilibrium. Okay. But in irreversible, changes takes place rapidly and system has no chance to be in equilibrium with the surrounding. Okay. Or second thing, driving force and opposing force, they are almost same in reversible, but in irreversible, driving force and opposing force, there is a large difference. Okay, now next part is modes of exchange of energy between the system and surroundings. Modes of exchange energy. Okay, so energy is mainly exchanged as heat and work. There are two main modes of energy exchange, that is heat and work. These are two modes of energy exchange, heat and work are the main modes of energy exchange between the system and surrounding. Okay. So let us discuss what is heat. Yes, heat energy. So heat energy, can you tell me what is heat? And when heat comes into picture? Yes, anybody who can know when heat comes into picture? Yes, can you tell me? Yes, yes, fast. Very good, Abhay. When, what is heat energy? So heat is defined as, it is denoted by Q, and it is yes, the exchange of energy which takes place on account of, and which takes place on account of temperature difference between the system and the surroundings. So exchange of energy which takes place on account of temperature difference between the system and surroundings is known as heat. Okay. So it means heat, we call it heat only, means energy is called as heat only when there is a difference in energy, difference in temperature between system and surrounding. Okay. For example, let us take system at higher temperature. Okay. So tell me, if system is at higher temperature, means it is at higher temperature with respect to surrounding. So tell me, what happened to heat? Heat goes out or heat comes in the system? Yes, heat goes out of the system or comes in the system. And second system is at lower temperature with respect to surrounding. Yes, so system loses heat. Heat goes out of the system. Okay. And if system is at lower temperature than the surrounding, then heat comes into the system, and these processes continues, this exchange of heat energy continues till both of them acquire the same temperature. In this case, heat is going out of the system so that system and surrounding acquire the same temperature, and in this case heat comes into the system, heat energy comes into the system, and it continues till both system and surrounding should have same energy, and for that purpose both should have diathermic walls, right? Then there is exchange of heat. For example, if we have boiled water, in a pan, cover it with the lid, what happened? After some time, its temperature goes down till it reaches equal to the temperature outside. Okay, and heat goes out. If we have cold water, फ्रिज से बोतल निकाल दो, ठीक है, तो क्या होगा? Heat goes into the cold water so that it becomes equal, right? So if it is transferred from surrounding to the system, that means if now we are talking about sign convention. So tell me, heat Q is positive, in which case? In first case or second case? Yes. Heat is positive when heat is positive when, yes, if it is absorbed by system. That means in this case Q is positive, means endothermic. Okay, and or we can say if it is transferred from the surrounding to the system. Okay, and heat Q is negative. Yes, tell me when it is negative. If it is transferred from the system to the surroundings, right? So positive when it is absorbed and negative when it is released. Good Siddharth, very good. Ralam, very good. Abhay, what you have deleted? Okay, so these are the sign convention. Means if Q is positive, heat is absorbed by the system, and if Q is negative, then heat is released by the system, absorbed by the system, released by the system. Okay, so this is about heat. So heat comes into picture when there is a difference in temperature between, yes, between system and surrounding. Now work. First one was heat energy. Now second one is work as energy. Okay, so work is, how many types of work are there? Tell me. Mainly there are two types of works. Electrical work so it is another mode of transfer of energy, exchange of energy between system and surrounding. So it is electrical work or mechanical work. Okay, conservative, non-conservative, that's great beta, that is the part of physics actually. Okay, anyhow, in chemistry there are two main types of work, that is electrical and mechanical. Okay, so electrical work means electrical work is done, yes, by passing electric current. For example, electrolysis of water. right? So when electrolysis takes place, the work done is called electrical work. Okay, but next one, other type of work is mechanical work, and it is pressure volume work. Yes, this mechanical work we have to discuss right now. That means if we have expansion work or contraction. For this, external pressure is required. We compare internal pressure with the external pressure, and this is common in gases, because both in solids and liquids there is hardly any change in volume when pressure changes, right? There should be a change in pressure, but solid and liquid, if we apply pressure, hardly there is any change in their volume, okay, because they are almost incompressible. So mainly this work comes into picture in case of gases. So in expansion there is increase in volume, in contraction there is decrease in volume. That means delta V equal to V final minus V initial. Okay, so in expansion, final volume is greater than initial volume. Let us take a beaker. There is a piston. Means this one is initial volume. Okay, now piston is expanded. When this expansion takes place, final volume is greater than initial volume. That means delta V is positive, and at the same time, what is the relation between external pressure and internal pressure? Yes, for expansion. Now contraction. In contraction, volume is less, so final volume is less than initial volume. That means now delta V is negative. So what is the relation between external pressure and internal pressure? Yes, tell me. In case of expansion, what is the relation between external pressure and internal pressure? Yes, very good. External pressure is less than internal pressure for expansion, and for contraction, external pressure should be greater than internal pressure, right? Very good, Ralam. What about others? I think you have got all this. What is expansion? What is contraction? Okay. So this is about delta V. Now work done during expansion. So what we do, we take an ideal gas only. Okay. This is the beaker. Okay. Now This is the frictionless piston. Now after expansion, this is the change in length. Let us take dl as the length. Okay, this is the piston at initial point, this is the piston at a final point. So change in distance is dl and area of cross section is equal to A. Okay. Now consider the ideal gas is enclosed in this cylindrical fitted with a weightless and frictionless piston. This piston is weightless. Why we consider it as weightless and frictionless? So that we should not worry about the pressure due to these things. So we take it as weightless as well as frictionless. This is the ideal case actually. Why we take ideal case? Because that is easy to understand. Because otherwise we will be in a fix when we count a piston with a weight, with a friction. So we have to count first friction, then weight of the piston, then pressure due to that. So we will we are ignoring the pressure due to lid, means piston, pressure due to friction. Okay, so this weightless and frictionless piston we are using. Okay, which is an ideal case. It is not possible to have like this. Even we don't have ideal gas. So we are enclosing ideal gas in this cylinder, and this cylinder is fitted with weightless and frictionless piston, and its area of cross section is A. Okay, and let us consider V as the volume of gas enclosed. Okay, and P is the pressure acting on the system. So far what we have done, we consider an ideal gas which is enclosed in this cylinder, and this cylinder is fitted with frictionless and weightless piston, and its area of cross section is A, or V is the volume of the gas enclosed, and pressure P acting on the system. And this pressure P acting on the system यस किसी भी गैस में बेटा नहीं होती है. आशीष, योर क्लास इज 8 to 9, 7:50 to 8:50. ओके, हाँ हाँ बेटा रालम, नो गैस इज एक्चुअली आइडियल. ओके, बट वी कंसिडर इट आइडियल so that we will ignore complex things. ठीक है. Now this pressure P acting on the system is slightly less. P is slightly less than the internal pressure of the gas. Why we consider it like this? Because we are talking about expansion work. So expansion takes place only when external pressure, that is P, is slightly less than the internal pressure of the gas. Okay, so that gas is in a position to expand. So that gas should expand. Now tell me, what is pressure? So pressure P is equal to force per unit area, that you all know formula of the pressure, that is pressure per unit area. So force, take it as F, area take it as A. That implies force is equal to pressure into area. Very good beta. Now suppose as a result of expansion, piston moves outward through a distance dl that we have already considered. So now small work by the gas on the surrounding, there is a work on surrounding. So what is work? Force into distance. So that small work denoted as dw, and that is equal to minus P into A into dl, because distance is dl. Okay. So this small work on the surrounding by the system, small work by the gas on the surrounding. This is the thing. Now why we write negative sign? So keep in mind, this is sign convention. In order to justify sign convention. Okay. So what is sign convention? Work done on the system is positive. Work done on the system is contraction work. Okay. And work done by the system is negative. So this is the work done by the system. Gas is the system. Got it? This is to justify the sign conventions. Okay. So minus P into A into dl. Now see, area into distance. So you know, area into distance is volume change, that you know all, that volume is equal to A into dl. So dw equal to minus P dv. Now to calculate the work done for the finite change from volume V1 to V2, initial volume V1 to final volume V2. So work done by the system is equal to minus P dv, and that is equal to minus P. What is integration of dv? The integration of dv is V1 to V2, that is equal to minus P into V2 minus V1, that is equal to minus P delta V. Okay. So this is the work done work done by the gas, okay, on the surroundings for finite change in volume from V1 to V2. Okay, so we get W equal to minus P delta V. So what is the work done during contraction? Work done during contraction. Yes. What is the work done during contraction? So in contraction, external pressure is slightly greater than that of gas, and that of the gas enclosed. So it will contract, and it is called work done by the system or work is done on the system. So now work is done on the system by the surrounding. So now W is equal to P delta V, okay, because now V2 is less than, say it remains minus P delta V, okay, but because V2 is now less than V1, so delta V is, you know that, final minus initial. So V2 minus V1 is negative. So negative negative become positive, okay, or you can write it like, let us take W as minus P delta V only. You know, P is positive, but delta V is negative, okay, or take its value as minus X, okay. So W becomes minus minus plus, so P into X, okay. So work done by the system means in expansion is negative, and work done on the system in contraction is पॉजिटिव. अगर आपको इंटीग्रेशन की बात करें, है ना, तो इंटीग्रेशन, हाँ, वी हैव टू लर्न दैट डेरिवेशन पार्ट. इंटीग्रेशन अभी तक इतना आया है कि अगर मान लिया वी हैव डी एक्स, ओके, सो इट्स इंटीग्रेशन इज एक्स. इफ वी हैव x into dx, integration is x raised to power 1 plus 1 divided by 1 plus 1. Yes, you have to learn derivation. So it is x square over 2. So tell me, if we have x square into dx, what is its integration? First case, it is actually x raised to power 0 dx. So it is equal to x raised to power 0 plus 1 over 0 plus 1. Okay, so you know this integration. Very good. X raised to power 3 raised to power 3. Okay. So first case, ये जो किया हमने, this is called irreversible work done, because here external pressure is constant. So external pressure, irreversible work is equal to minus P external into delta V. So this is irreversible work done. Okay, so that's all for the day. Okay. Next is work done in an isothermal and reversible expansion that we have covered. We will cover tomorrow.